This is a video about the topic of area. The previous video we just talked about was about perimeter, and in that video we said there are things we measure about shapes. So perimeter was one thing that we can measure about a shape. It is the distance around the outside of a shape. And you might notice I'm emphasizing two words there. The distance, number one word, around the outside of a shape. In this video, though, we're going to talk about area. So area is another term that we use outside of math. So let's just think of an example. Someone might have moved into my neighborhood and asked me something like this. Is there Tim's in the neighborhood? They might ask that question this way too. Is there a Tim's in the area? And by area they mean neighborhood. So is there a Tim's in the area? There's the word area. What do they mean when they use the word area? Do they mean one spot? Well, what they mean is kind of, if this is, well, I'm thinking of the neighborhood where I live, so they say this is King Street, and here's Weber Street, and here's Victoria Street, and here's Union Street. When they say is there a Tim's in the area, they're kind of covering this whole spot in this whole neighborhood area. So that's a helpful mental image when you're thinking about area. It's not one spot. It's not the outside of something. It's the inside space. It's the space on the inside of something. So that is what I would say is a helpful definition of area. What is area? Area is the space on the surface of a shape. So in the example of the neighborhood, the shape was a rectangle that was bounded by King Street, Weber Street, Union, and Victoria. And the area that is my neighborhood is the amount of space on the surface of that rectangle. That's what I'm going to call area, the definition of area. So you can see that area is different than perimeter. Perimeter was not a space, it was a distance. Perimeter was not on the surface of a shape. Perimeter was around the outside, distance around the outside. So this is quite different than perimeter. So let's look at some examples where people might use the idea of area when they are working on something. Actually, before we do that, let's talk about what are the units of area. Well, since we draw the neighborhood again there, when we're talking about area, we're not talking about the distance around the outside. Instead, we're talking about how much space is there inside. How much space is there inside the shape, the yellow space that I'm shading there. So, well, how can I figure that out? The way that we figure out how much space there is in something is by breaking the space into squares. Squares that are all the same size. And then we count up how many squares of space are there inside that shape. So in this shape, I could say there's 1 square, 2, 3, 4, 5, 6, 7. Well, to make this faster, I could add them all up. But let's count. I've got 7 squares across the top and 1, 2, 3, 4 squares down the bottom. So if I've got 7 squares across this way, 4 squares up and down this way, that means I've got 4 sets of 7. 7 in the first row, 7 in the second row, 7 in the third row, 7 in the fourth row. I've got, in other words, the number 7 4 different times. And I know from using mental math that 7 times 4 is 28. So number of squares I've got here is 28. So I could say that the area of this rectangle that I've drawn is 28 squares. 28 squares. So when I'm measuring area, area is measured using squares. Really different than perimeter. Perimeter was a distance. So we measured it with things like centimeters, meters, feet, inches, miles, kilometers, but area is different. Area is not a distance, it's a space. And we measure space using squares. So now, how big are the squares? Well, this is where we can say, let's get back our title again so we remember what we're talking about. We're still talking about units of measurement for area. If I'm measuring the area of something small, I might use a square that is just, and remember the thing about a square is all four sides are the same. So I might use a square that is 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter. And the amount of space inside that square, this might make a lot of sense, is 1 square centimeter. 1 square centimeter of space. Now, another way to write square centimeter would be 1 centimeter with a little 2 up here. The 2 saying that it's squared. If you know, putting a 2 on the shoulder of a number is a way to square it. But another way to think of that little 2 is that now we're looking at a shape, or the idea of area. We're looking at something that is two-dimensional. It's got a length and it's got a width to the idea of space. So if I'm measuring something, the space on something that is small, I might use square centimeters. If the thing that I'm measuring is much bigger, let's say the floor space of a house, I might decide to use, and this is a common term of measurement for how big the floor space in a house would be, I might use a square that's 1 foot by 1 foot by 1 foot by 1 foot, and the amount of space that that square covers would be, can you guess it? 1, and what's the shape again? Square, and how big are the sides of the square? Foot. 1 square foot. Another way to write that, 1 foot with a squared on the shoulder, or even shorten it up to 1 square foot. So I'm looking at the floor of my kitchen right now, and on the floor of my kitchen there are floor tiles. And if I got out my ruler to measure the floor tiles, they are exactly this size, 1 foot on every side, which tells me they're a square. So every tile on the floor of my kitchen covers the space that is equal to 1 square foot. Now, if we're measuring the space of, let's say, a region, then like Waterloo region, then we might need a much bigger square. So we might want to use a square that is 1 kilometer big on every side. 1 kilometer, 1 kilometer, 1 kilometer, and the amount of space that that square would cover would be 1, and the shape again, square, and the size of the square, kilometer. 1 square kilometer. There. So that's how we talk about units of measurement for area. Units of measurement for area. So we've just mentioned a couple of common uses. Common uses for measuring area. One is, I mentioned my kitchen floor. So if this is the size of my kitchen, and let's use the previous example. Let's say that this is 7, oh, that's going to be too small. Let's change it up. 14 feet is the length of that wall. And let's say that 10 feet is the length of this wall. And I want to know how many square feet of space inside this on the floor of my kitchen, because when I go to the hardware store, flooring is sold in packages and it tells me how many square feet of space the flooring will cover. We buy carpet in terms of how many square feet of space it will cover. If I'm buying floor tiles that are squares that are 1 foot big, then I will need to know how many square feet are in my kitchen to decide how many square foot tiles to buy to cover it all. So to figure this out, I might again imagine that I'm going to measure and imagine that I'm breaking this side of the kitchen floor up into 14 different squares, every square being 1 foot, 1 foot, 1 foot, 1 foot. So I've got a row of 14 squares there. Now, if I go down to measure my second foot down, I'd have another row of 14 squares and another row of 14 squares. I'm going to have 10 rows of 14 squares. How many squares altogether? Well, one way I could say that is 14 squares in the first row, plus 14 in the second, plus 14 in the third, plus 14 in the fourth, plus 14 in the fifth, plus 14 in the sixth, 14 in the seventh, plus 14 in the eighth, plus 14 in the ninth row, plus 14 in the 10th row would equal, and I have no idea because that's a lot of adding to do. So the floor space, that's one way to find it. But we know that multiplying is a shortcut to adding the same number over and over and over and over again. How many 14s did I have here? I had 10 14s. In other words, I had the number 14 and I had it 10 times. Oh, well that I can do because timesing by 10 is pretty quick. I can do that in my head. I just add a 0 to the 14 and I get 140. 140 what? Well, we're counting squares. Square what's? Well, what's the size of the square? Well, they were 1 foot by 1 foot. The floor of my kitchen has a space that measures 140 square feet. So if I'm going to go to the flooring shop and buy some flooring tiles, I'll need 140 tiles that are 1 foot by 1 foot square, or 140 square feet of carpet, or 140 square feet of linoleum, whatever it is I want to cover my kitchen floor with, because we're covering space. Baseboard, if I wanted baseboard, then that reminds us again of perimeter. Remember, perimeter is really different than area. Perimeter is the distance around the outside of a shape. But area is the space that is inside a shape. So there's one example of where we would use the idea of area. Here's another one. I'm going to paint this wall in a room. How much paint do I need? Well, we know that I am not going to paint just around the outside of the wall. No, that would be silly. What I am going to do is I'm going to paint the whole space on the wall. Well, if I'm painting the whole space on the surface of the wall, then to talk about how much needs to get painted, I'm talking about painting the space. That's the idea of area. Remember, the distance around the outside would be perimeter, but talking about paint, this would be area. I would need to know area to talk about how much would be painted. So again, I'm going to break this up into squares. So let's say that this wall was 12 feet long and a wall is usually 8 feet high. So to find out how much space would be on this wall, I could start by taking and measuring how many squares would there be across the top. Well, there would be 12 squares across the top if every square was 1 foot by 1 foot. Now, this number here tells me I'm going to have 8 rows of those. Here's my second row of 12 squares, third row of 12 squares, fourth row of 12 squares, and so on until I get 8 rows of 12 squares. How many squares altogether? Well, to find out the total amount of space, which again, the word we're using here is area, I could say that's, well, 12 for the first row plus 12 for the second row plus 12. And you're probably already saying there's a much faster way to do that. we've got 12 squares, and we've got that 8 times, and I know from studying my times tables, 8 times 12 is 96. 96 what? Well, we're counting squares. Square whats? Well, these squares are 1 foot by 1 foot. This wall, not counting for the door, at this point I'm imagining I haven't subtracted the door from this, but it's not going to make a huge difference, so I'll just end up with a little more paint than I need because I'm not painting the door. I'm going to go to the paint store and say, the wall that I'm painting is 96 square feet. What size of a paint can do I need to have enough paint to paint a wall that is 96 square feet? Now, they're probably going to say, well, you need 2 coats. Aha. So then I need, well, let's round this off and make it easier for ourselves. Roughly 100 square feet to cover the wall. 2 coats. If I need 2 coats of paint, then I'm going to have to buy enough paint to cover 200 square feet. And then the hardware store will help me to find a paint can that will have enough in it to cover 200 square feet. Right on the side of the paint can, it'll say, will cover 200 square feet, or 300, or whatever the number is. Now, just like with perimeter, there are formulas. Formulas is, I'm going to use formulae for area. For perimeter, the formula depended on the shape that we were talking about. So we started with squares with perimeter. So for a square, we know all the sides are the same. Side is the same as that, is the same as that, is the same as that. From all the examples we found, we said, okay, so how many feet do I have in the top row? And then times that by how many of those rows I've got. So the number of feet in the top row is going to be the same as the number of rows that we're going to have. So the area of a square is going to be S times S. And a shortcut for saying that is S squared. There's that square thing showing up again because we're counting area by squares. If it's a rectangle that I'm counting the area of, then it's going to have length, and opposite sides in a rectangle are always equal, and width. The area of a rectangle, and lots of people will remember this formula, is length times width. Notice that just like the formula for squares, we're timesing 2 things. And here again, we're timesing 2 things. Up here, the 2 things that we were timesing were this length and this length, and they just happen to be the same. In this, we're multiplying this length and this length, but because they're different, we're doing length times width. We can also calculate the area of a circle. Now, a circle doesn't have any straight sides, so the formula here is going to be really, really different. With a circle, we're going to need to know radius. Radius is like the spoke of a bicycle wheel. How far from the center of the circle to the outside edge? Just like one spoke. So the area of a circle is equal to pi, which is that really mysterious number of 3.14 that goes on and on forever and ever and never stops. Pi times radius squared. There's that squared showing up. And the units of all of these, when I get my answer, will either be square centimeters, square inches, square feet, square miles, square kilometers, square meters, square yards. You get the idea. These are all going to be area measurements, are always going to be in squares because that's how we measure space.